So today, class, we will be discussing. Robert, wake up! Oh, read it! Now we can begin our discussion about limits.
Hello, class. Today we'll be discussing limits. The limit A, per se, is the value that a graph will converge to at that point A.
To find the limit, one must approach the desired point from both the left and the right. If the two answers are equal and hit, then the limit exists. If they don't, then it does not.
Now we will look at an example with point A being equal to 0 for these graphs. Let's see if the limit exists.
Our coordinate plane, y-axis is the blue, black is the x-axis, and this is our graph of x squared.
I am the limit as x approaches A from the left.
I am the limit that approaches x from the right.
This is the limit as x approaches A on a sine graph.
Hello. We're going to look at the limit as x approaches 0 of x squared here. And what we need to do is find out which point the graph is going to converge to at x equals 0. So we look at it from the right first. We're going, oh, all the way down to 0. We're thinking, where's this graph going to go to? That graph's going to think it's at 0. What about from the left side? We don't know. So we're going to come down from the left. We're thinking, oh my god. Think it's going to hit 0? I don't know. Maybe. Yeah, it'll hit 0. And since from both the right and the left are going to equal 0, the limits are, we're going to think, the limit does exist. Since they both agree that the limit will be 0, the limit is 0.
So, class, now we will be looking for the limit of the graph of sine of x. This you will have to look for the limit as x approaches 0 from the left and from the right. So, from the left, it is going up. 0. Yay! So, left. There. 0. And from the right, it's going, and what do you know? 0 again. From the right, it is 0. Since they both equal the same thing, the limit is 0. Yay! Of a step function. Here we go. But now, only as x approaches from the right. Now this time, from the left.
Hi! Let's look at the graph of integer x plus 1. Changing up, going crazy, having a happy time right now. Okay, so we're going to look at the limit as x is approaching 0 of integer x plus 1. So to do limits, we all know this deal by now. You got to look from the right and left, and they need to agree. So let's look from the right. We're thinking, graph is coming to 1 at 0. So that's going to equal 1 when the graph is going to 0. But then, let's look at from the left. From the left, it's going 0, 0, 0, 0. I think it wants to be 0. Let's let it be 0 because it is 0 when you look at it from the left. And then we go, okay, 1 is 0, 1 equals 0. We go, it does not equal 0. Bad graph. So then the limit does not exist. It is a bad graph. The limit doesn't exist because the limits don't agree from both sides.
And what if there is a horizontal asymptote at x equals 0?
This time, class, we're going to be doing limit of 1 over x as x approaches 0. See, let's check here. We got to check from the right for the left. So first from the right, it's going to be going, goes to infinity. Positive goes to positive infinity. Alright, let's check from the left. It's going. Oh, goes to negative infinity. Positive infinity equals negative infinity? I don't think so. That means y equals 1 over x does not, no limit.
Now we'll look at a graph when x doesn't equal 0.
Oh, one more time, please. We're gonna look at the graph of y equals 0 now. The graph, y equals 0, and there's about negative 160-ish. Okie dokie, so the limit is x is going to 0 of this graph. But the trick is, x cannot equal 0. There's a big gaping hole at 0. The graph does not equal 0, okay? Okay, let's see what happens. We're going from the right here, just like every other limit, right? We're coming from the right, we're going, wee, this is fun! And then we think, the graph doesn't equal 0, but it thinks it does. It's a little cuckoo. So, sure, we'll humor it and say it equals 0, because it thinks it does. Now, from the left, we're riding along, going, having a good time, and we get to the same situation where we're thinking, there's no point there, but what does it matter? I mean, look at that. Heck, that could be 0. We wouldn't know. So, go from the left equals 0, and then think, does 0 equal 0? I don't know. Looks like I got a little bicycle there. But yeah, it does. So, this is happy time. The graph equals 0. The limit exists. And the limit will be 0 when x approaches 0.
And now, for the final battle.
Does the limit exist?